Hi everyone, I'm Rakesh Theatre and welcome to Theatre Essence. Today I'm going to deep dive into artificial intelligence. By definition, it is science and technology of creating software systems that make machine intelligent with the ability to learn, understand and apply knowledge. So when we see a cloudy sky, our brain predict it might rain. That's our intelligence at work. Similarly, AI makes machine act smart, just like the human brain, providing ability to learn, give reasons, predict answers, recognizing patterns, making decisions, and so on. To understand artificial intelligence, I can compare it with a dog so that it's more easier to understand. A dog sits and fetches with repeated commands and rewards. Likewise, AI learn from large amount of data, applying knowledge like what is right and what is wrong. That's AI training. Next, a dog starts to develop cues like hand signals, voice of tone. Likewise, AI model can help predict patterns. Lastly, a trained dog, given the command, it can perform tasks. Likewise, through AI model, AI can give answers or predict or maybe act when given a prompt or a query. So I hope this pet dog analogy clarifies what really AI refers. To further deep understand artificial intelligence and its core, let me take another interesting analogy. This time, I'm going to compare it with onion that we often use to cook in the kitchen. Since artificial intelligence is a massive topic, let's just simplify it as a simple onion. A simple red onion equivalents to artificial intelligence. Sounds strange. Once we peel few layers of onion, the remaining onion becomes machine learning. So we can think machine learning as a subset of artificial intelligence. Next, we peel more onions and more layers. The remaining onion becomes neural network. So in that sense, neural network is a subset of machine learning. Again, if you peel few more layers, the remaining becomes deep learning. So deep learning is a subset of neural networks. So really there are three core aspects of artificial intelligence. One, machine learning. Second, neural network. Third, deep learning. And each of these three topics have their own variants, their own algorithms, their own purpose and models. I will be deep diving into those shortly. If you like what I am presenting or how I am presenting, please support Tata Essence by subscribing. If you haven't already subscribed, please kindly subscribe. Machine learning. As I mentioned earlier, machine learning is a subset of artificial intelligence. In other way, we can also consider it as a branch of artificial intelligence where machine learn patterns from data and improve their performance on tasks without being explicitly programmed. For example, instead of hard coding rules to detect spam emails, you feed a model thousands of emails labeled spammed or not spam. This way, the model learns and can classify new emails on its own. Based on the training approach and strategy, we have several types of machine learning. Among those, I'm listing 6 types of common learnings below. So the first one is supervised learning, which is about learning from labeled data. The second one is unsupervised learning, which is about learning from unlabeled data. The third one is semi-supervised learning, and it's a mix. It's about learning from a small amount of labeled data plus the large amount of unlabeled data. The fourth one is self-supervised learning, and it's about learning from labels which are automatically generated from the data itself. The fifth one is the reinforcement learning, and it's about learning by trial and error, where it is guided by rewards or penalties. It further has 3 types of variation, which is popular. 1, value-based, 2, policy-based, and 3, actor-critic, which is combination of both value-based and policy-based. So the next topic is neural network. As I mentioned earlier, neural network is a subset of machine learning. It is a type of machine learning model inspired by the structure of human brain. It consists of layers of interconnected neurons that process data by applying weights and activations to detect patterns and make predictions. For example, a neural network can take an image of a cat, process it through several layers, and correctly identify it as a cat by recognizing patterns like shapes, edges, and textures. So based on the model architecture, here are some of the most common types of neural networks. First one, feed-forward neural networks. This is the simplest type of neural network, where it has layers of neurons but without any loops. And therefore, it is also known as multi-layer perceptions, MLPs in short. On the feed forward, data only flows in one direction, so from input layer to the hidden layers and eventually to the output layer. So the second type of neural network is convolution neural networks, CNN, and it is commonly used to extract spatial features using filters and heavily used in image data such as image, video, and medical scans. Third, the recurrent neural network. This is another popular neural network. The specialty of this neural network is that it maintains memory across time step. For example, when you first provide an input through the first layer processes it and generates an output. Along with the output, it also maintains the memory of what has been processed. So in this layer, it provides both the memory as well as the output to the next layer. And we have few variants on recurrent neural networks. The first one is LSTM, which is long short-term memory. And the second one is the GRU, gated recurrent unit. So the fourth neural network types is the transformers. It handles sequential data with attention mechanism, i.e. weighted importance of different inputs. So in this, it not just takes the input, but also applies the weight of the input. This is the backbone of modern natural language processing, NLP. So the fifth one is the generative models. Again, a very popular model. So in generative model, it learns patterns from data and it has ability to generate new pattern or new data based on the previous data. So instead of predicting a level, it can create new samples like text, images, audio, and so on. The generative models also have few variants. The first one is GANs, which is generative adversarial networks. The second is variational autoencoders. And the third is diffusion models. Next, the graph neural networks. This neural network works with graph structured data and it's mostly used in social networks. The last one is the hybrid architecture and it's the combination of neural networks. Example, you can combine CNN plus RNN. You can combine transformer plus generative models. Deep learning. Deep learning is a subset of machine learning that uses neural network with many layers, hence known as deep, to model complex patterns in data. Each layer transforms its input into a more abstract representation, allowing the network to learn hierarchical features. Based on the purpose, here are some of the most common types of deep learning. The first one is the discriminative model. This model focuses on classification or regression. The second is generative models. This model has ability to create new data from the input data. Third is the representational learning. This model learned useful features like embeddings or representation from raw input data. And the fourth one is the deep reinforcement learning. This is the combination of deep learning and reinforcement learning. So this ends the deep learning. I have also highlighted some of the key notes in this. If you'd like to read more, you can visit my blog site. So to summarize, I'll just quickly review the hierarchy of artificial intelligence. Again, artificial intelligence on the top, then we have machine learning, and under machine learning we have supervised learning, unsupervised learning, neural networks, and reinforcement learning. And under neural networks we have deep learning. So I've added some variation types for each of these learnings here, which I did not cover earlier. Again, please feel free to read more from my blog site as well as other resources. That's all about artificial intelligence. I hope you have gained some useful information through this deep dive. Again, please kindly support Data Essence by subscribing. Let's join together in the journey of Data Essence and grow together. Thank you once again, and stay safe.